Welcome to Grade 10 ICT tutorial. In the last video tutorial, we had an introduction for different numbers or different number systems, and also we listed the characteristics and their behaviors which may differ from one number system to another. If you didn't watch my first video, please take some time to watch it, because without those fundamentals, without those basic concepts, it is very difficult to understand the today's lesson. So I recommend those who didn't watch the first video, please go back and watch it, and then only you can understand the today's most important part, which is conversion. So I take a minute or two to recall what we had on the other day. In the last class, we introduced 4 number systems. I named them as decimal number system, binary number system, hexadecimal number system, and octal number system. So we have 4 different number systems. All these 4 different number systems use different digits or symbols for forming the numbers. Decimal number system has a range of digits, binary has different range of digits, and octal even has different digits, and hexadecimal is slightly different than the other 3. So we got some basics in the last tutorial. So today we will start the most important part, that is conversion. So hereafter we have to convert a number which belongs to one number system into another. So since we have 4 different number systems, definitely there may be, or there should be, 12 different conversions. So these conversions are very important for your examination. Even in the final GCO level examinations, questions are often asked in this area. So watch it carefully. Try to understand the methods which I mentioned or I suggest, and most importantly, you have to practice and remember. This is not the subject to memorize, so you have to follow my steps. So first of all, we take the first conversion, that is very simple, converting a decimal number into a binary. So straight away I write here decimal to binary. So better I take a simple example. Let me take 20. So let's find out the equivalent value for 20 in binary number system. So 20 is written in decimal number system, so definitely there is an equal value in binary. Let's find out. So to find out the equivalent value in binary for decimal 20, we have to do a simple calculation, simple process. Have a look at this. I will write that calculation here. So this is 20. You have to find the binary. So it's very simple. So binary, the base of the binary number system, as we already studied in the last class, the base value of the binary number system is 2. So divide this 20 by 2. So remember one thing, as much as possible, you have to divide this 20 by 2. So divide it first. So 10 times. So here, when you divide a number by another, sometimes there may be a reminder, sometimes there may not be a reminder. Look here, 20 is divided by 2, so it's 10. We don't have any reminder, but put the reminder, because we have to write the reminders as answer. So here, so you don't have any reminders, so put that as 0, right? So divide that particular 20 by 2 and you have 10 times and remainder 0. As I told you earlier, you have to divide that number as much as possible. So divide it again. Divide further. Again by 2. So 5 times. Here also you don't have any remainder. So remainder is 0. So 5. So it can be divided. So again by 2. 2 times. Here the remainder is 1. You have 2, divide it again, so it's 1. Here you don't have any remainder, put that as 0. See, if this becomes 1, it doesn't mean that you are unable to divide it again. See, look at this, it's a number. Even though it is smaller than this 2, it can be divided. So divide again. So yes, it's a small number, so it is not included, put the 0. And you have that particular one is the remainder. 1 is the remainder. Now look at them, it becomes 0. So which means hereafter you cannot divide that particular number, because when this number becomes 0, it means it is divided. So at this time you have to stop it and put the reminders. So here when you write the answer, you have to write the reminders as the answer. But you must be very careful when you write, when you are writing the answers, make sure you write from the bottom to top. So here it is 1 0 1 0 0 base 3. Right? So I just want to mention, also, explain again. So when you want to divide a decimal number by, so when you want to convert a decimal number into binary, you have to divide that particular decimal number by the base of binary. Here the base is 2, so you have to divide as much as possible. Once it is 0, you have to stop your division. So generally in mathematics, so have a look at this, 20 is divided by 2, so 10 times. So even though I used to call that as times, 10 times, in mathematics it is called quotient. The number of times should be called quotient. So until the quotient becomes 0, you must divide. That's a very simple idea. So here you have to put the reminders. Reminder values. Right? So make sure the reminders are written from bottom to top. That's the answer. Hope you have understood this small idea, small method. So if you have any doubt, we will discuss at the end of all these 12 conversions. So I straight away go to the second conversion. So here the second conversion is decimal to octal. Converting a decimal number into an octal value. So before we start this conversion, I want to outline or highlight something here. So look here, in decimal to binary, you have divided that particular 20 decimal number by 2. The reason for dividing this 20 by 2 is the base, binary number system. The base of the binary number system is 2. So you have divided by 2. So just apply the same method here. Look here, I take a number 50. 50 is a decimal number. Let's find out the equivalent value in octal. Let us use the same approach. So I want to write the method here. So it's 50 here. Here we divided by 2 because it's binary. So here we must convert this into octet. So divide this decimal number by the base of octet. So which is 8. This may be the only difference between these two conversions. Here we are dividing by 2. Here this number is being divided by 8. So here better write the quotient first. 6 quotient and the remainder is 2. So hope you remember that particular one which I mentioned again earlier. Until the quotient becomes 0, you have to divide. So further divide. So since 6 is smaller than 8, so it is 0. So put the 6 here. Now the quotient is 0, so you cannot divide again. So stop it and get your remainders from bottom to top. So here 50 is equal to 6 to base 8. So these are the two conversions, first two conversions. Both of them have similarities, similar approaches and similar methods. So hope you understood both of them. Let's take the third one. Even the third one also, now you can easily guess the one which I'm going to explain, the conversion which we are going to take. So yes, it would be decimal to hexadecimal, and also even without any explanation, you can find out or you can get the method which is used for converting the decimal into hexadecimal. So let's take one example. I'm going to write this. So number 3, decimal to hexadecimal. So let's take a number. Okay, I take the same number as I took earlier, 50. So let's find out the equivalent value in hexadecimal. So same method. Divide that 50 by the base of hexadecimal. So in the first conversion, we divided the decimal number by the base of binary. So we divided by 2. In the second conversion, we divided the particular number 50 by the base of octal number. So we divided by 8. Now it's going to be decimal to hexadecimal. So this has to be divided by the base of hexadecimal. So as we discussed earlier in the last lesson, the base of the hexadecimal is 16. So divide by 16. The other things are same as the previous. So until the quotient becomes 0, divide it. So 3 times 3 quotient, 2 remain. Now look. 3 is smaller than 16, but it is further divided. So divide it again. It's 0 times 0 quotient, and it will be, put the 3 here. So this becomes 0, which means we cannot divide that hereafter. So stop that and get your answer. So here 50 is equal to 3 to base 16. But whenever you convert a number into hexadecimal, you must be very careful. So it is always possible for making mistakes when you convert a number to hexadecimal, because hexadecimal is the one and only number system which uses both digits or numbers and alphabets. So there is always a possibility for making mistakes. So let me explain one more example. So let me take 110. I take a decimal number 110 and I'm going to convert this into hexadecimal. So I follow the same method. have to divide by 16. So 110, 16, so it is 6 times 6 quotient, and it would be 14 remainder. Look at the quotient is 6, so which means further divided. So divide again 0 and put this 6 here. Right? So we have divided. Get those reminders as answer. So as a student who did all these previous conversions, you may try to write like 16, 14, base 16. This is possible because even in the previous 2 conversions, we did it. We divided and got the reminders from bottom to top. So here also I divided and I have reminders. So as a student, I am trying to write from bottom to top as I did earlier. But this is wrong because even though the method and everything is correct, the answer cannot be written like this because we all know that 14 is a valid digit in hexadecimal. There is no issue at all. But note, 15 cannot be written, 14 cannot be written in number, because in hexadecimal from 10 to 15 we use alphabets for representing the numbers. So since you have 14 here, you cannot write 14 directly. You have to write the English letter which represents 14. So 6, okay, it's in the range 0 to 9, 6, okay. So 14 must be represented. Hope you remember that order. 14 must be represented by E. 6E base 16. So that might be the issue, or that may be the one which student always makes mistakes in examination. So you must be very careful when you are dealing with hexadecimal numbers. So today we got 3 conversions. I started off the lesson with decimal to binary, and then we did decimal to octal. Just now we have done decimal to hexadecimal. So remembering and understanding all these 3 conversions is very simple because see, you can see a pattern there, you can see a method there. So just remember the method. So the fact is very simple. The summary is very simple. If you are trying to convert a decimal number to any other numbers, make sure you must divide that particular number by the base of that number system which we are going to convert. So if it is decimal to binary, you must divide that decimal by the base of the binary, which means 2, and write the reminders. If you are trying to convert a decimal to octal, divide that decimal number by the base of octal number, which is 8. Finally, if it is decimal to hexadecimal, divide the decimal number by the base of hexadecimal, which means 60. So if you remember this very simple summary, this never be forgotten. So I have done 1 example each for all these 3 conversions. In fact, for 2 only for decimal to hexadecimal. For other 2, I took only 1 example. So try spending some time in watching this video again. Even you may take some other examples, other conversions, other examples for converting these 3 for your practice. So try practicing this video. In the next video, we will take the opposite conversion, vice versa, of these 3. So today we did decimal to binary. In the next video, we will take how to convert a binary into decimal. Today we did decimal to octal. So in the next time, we will take octal to decimal. Here we did decimal to hexadecimal. So in the next time we will see how to convert hexadecimal into decimal. So hope you all can spend some time in watching this video and practice some examples. So with that particular knowledge, we will meet in the next lessons or next video. Thank you for watching.